We are about to begin the run of Team SNU. They have 12.5 points from yesterday's run. We will see if they can beat that overall score. We look forward to see how their speed change and adjustments overnight may occur. Also, a new operator. Again, this is what's fresh and new each time. Train somebody and let them take over your multi-million-dollar, multi-year developed system.
Always exciting every time they come out on the course.
Here we go. First task, of course, is to get off that line and make it to Mission Command to receive those instructions. Each task must be completed in a way that the judge backstage, who is the task judge, can approve of that. As you can see, it's about 15 to 17 feet to navigate, to get inside that yellow rope, approach that number 2, and receive those communications.
This is Bill. I've come for the mission.
Greetings, Bill. I'm Mission Commander Tom. Thank you for your assistance on this important mission. Now, the mission has several steps, and it will take a high degree of Avatar operator skill to complete. First, make your way to the station hatch. Locate the switch to open the hatch. Flip it to on. When the hatch opens, pass through it over the planetary surface to the power station. At the power station, locate which of the power canisters are full and take a full power canister and place it in the slot. This will power the lights for the asset storage area. Maneuver to the asset storage and using the drill, open the access hatch. Reach inside and feel, using the sense of touch, for the rough rocks. Find a rough rock. This is your energy abundance rock. Retrieve the energy abundance rock and your mission is complete. Now, I know that's a lot of instructions. How do you copy?
Okay, Tom, I've got the switch to flip up and then enter the area where I find the full fuel canister. I'll place the full fuel canister in the pod and then proceed to the energy storage area where with the drill, I will open the hatch in front of the rocks and pull out the rock that has the rough texture and retrieve that.
That's correct. Good luck.
Okay.
And hurry. The clock is ticking.
Okay, thank you, Tom.
A very polite exchange. Operator Bill and Mission Commander Tom. 2:30, it's about the time for Team SNU that exactly where Alter Ego left Mission Command right at 2:30 as well, so the pace is about the same as the previous team. We can see here that SNU has a bigger, the four-wheel base, which we've seen in several of the platform things, but then sort of a humanoid sitting on top of that base.
And when we talked to the team on Wednesday, they had mentioned that at one point they had been studying walking, and at this competition decided that just wasn't the right modality, and I tend to agree with them for what we have as terrain.
Right. If the terrain in the 75-foot long run was different, the choice might be very different, but this is a pretty smooth, open terrain for the big run. Team SNU now approaching that switch. And you can see the operator in this one. It's one of the bigger interactive things on 2 standing vertical controls, but each arm receives its own system.
These systems are very cool. They're going to give you kind of a sense of where your robot is and being able to do the things it needs to do, provide the force feedback. They are a little bit harder to get into and can, in some cases, provide a little bit more fatigue on that operator if there's too much pushing in areas that they don't expect.
Switch successfully thrown. Achieve that just under 4 minutes. That's a pretty good time. Again, right on pace with where Alter Ego was. So as we've seen, some of these early timings work out to be about the same. The run, depending on the comfort of the operator judge and the system, to the canisters is where some time can be made up. And then obviously completing these last complicated tasks is where almost all the time in these runs has been eaten up.
Yeah, I think we had about 5 teams yesterday get through opening that hatch on that drill, using that drill for that hatch. Team SNU didn't quite make it there. The drill has kind of bogged down folks. So we'll see if we can go, if there's any adjustments made last night that will help support using the drill for that 9th task.
Yep. So you can see in the heads-up display, this is one of the stitched together viewpoints. This is Team SNU on the course right now. Let's meet them. Let's hear more about them.
Our team name is Team SNU. It's from Seoul National University. Our avatar system uses our own humanoid robot, which is very unique. This is a research platform that we wanted to study to build a humanoid robot that is very similar to human capability. So it can walk around and can manipulate many things as human does. And it is in a compliant way that it can interact with the environment and human in a safe way.
So our robot began with just 2 legs. It was really a research robot for bipedal walking. Specifically for the Avatar XPRIZE, we worked on the head and a way to communicate and interact with people.
And also, we have been developing our haptic interface uniquely for this competition. So this is all developed by ourselves, which is a little bit different from our teams.
As a research lab, we're really focused on control theory and how to operate robotic systems and advance the field in that way. Understanding the public's perception and how regular people that are outside of robotics understand that robot is really powerful.
We've been watching Team SNU at that drill station trying to get a grasp that's stable, secure, and dexterous enough to pull that off the case and get to work on the bolt. We're at 21 minutes. It's been a task. It's been a task that's undone many of the teams, Julia.
Right, including SNU yesterday. So definitely something that is hard to do from a standpoint of the structure of this robot. More than one operator is having some difficulties with this. I wish he would just go to his left hand. Left drill is better.
It is still the human element that makes this competition so utterly fascinating and unique to see how things unfold. Obviously, more than likely a right-handed operator, just trying to make that hand on the avatar system, grab the drill in the right place to have enough stability to then fire the index finger to grab the trigger, right? So it's a multi-tiered task. The weight of that drill, it's a big product placement spot, by the way. We should look for that in the future. The battery is the heavy part of it. Now, dynamically, what's interesting is this tool case that is the top of it. Obviously, it looks textured. It is not. That is a slick steel surface, slick metal surface that these drills keep just sliding around nonstop.
Right, and I think a frustrating part, for these teams when they have different operators coming in, there are operators that have maybe more strategies in their head in the first place to go and try, and then there's some that are just very patient and persistent and trying to do what, as they're trained and how they know that the team told them, hey, this is how you want to do it. So it's, I don't even want to pretend to think what the team wants more, depending on, the situation. But those personalities, they really do make a big difference in these scores.
And this is an enormous part of this task, the ability, the agility of the machine itself on the course, but that 60 minutes of training someone to be ready to go on this. And the idea being, right, let's make an agile enough system, a robust enough system that anyone can do it. Should we be in a situation where an avatar is necessary to achieve something that's dangerous, dull, dirty, all our Ds, right? That's what we're looking forward to in this technology, but most importantly, at the dangerous level of it. If this was an operator in a habitat, but perhaps it's not the science officer in the habitat, or perhaps it's not anyone with mechanical engineering experience, maybe, Julia, you're taking a nap, and so somebody's got to go get something done right away, like me, who's not really well-versed in any of this science. And I've got a quick checklist, and we've got to go get this rock before we lose power.
Yeah, the human-computer interaction, the human-robotic interaction part of this is a really important thing. You need to feel like the avatar is part of your team, is part of your extension of your body, all of those things. And so from a standpoint of the comfort level and ensuring that system can do that from the interface all the way to the output of that system is an enormous task.
It's an absolutely enormous task. And this is something, the human-robotic interaction is a field growing exponentially. How rapidly is that field going to be not just essential, but an enormous part of our mainstream understanding of what we're doing with technology?
Absolutely. I think it's a huge field now, and it's going to just continue to grow. It's not just robots, there's the computer systems and being able to trust them and have them part of your overall standpoint. And I have to say, there's a door at work that, instead of pushing, it looks like you should pull, and so it's not even just those sorts of things. It's all over the place, And so it's an absolutely important part of using tools in our systems and being able to move on and advance in this is to make that human interaction smooth as possible.
So we've reached time